Hi, this video I would like to share about time series analysis. Time series analysis means when we have a data with time, we can find some conclusion, we can extract some patterns from it, we can identify the trend, the seasonal element from the data, and also we can forecast, we can predict the future values also. So time series analysis is a statistical method or technique to find out the hidden patterns, trends, seasonal elements, and forecast the data with time. So let's go through the definition. A statistical technique used to analyze data collect over time in order to identify the patterns, trends, seasonal effects, and make forecast. So, and why it is important? Just imagine. So, this time series analysis enable organization to uncover hidden structure in the time order data to make some predictions, and also we can use for the future evaluations. Like for example, if we can predict the future sales, we can collect the stocks as per that, and we can make necessary uh, resources for that operation. So that is the relevance of time series analysis. So it is very important. Just understand about the basics. So there are four components for time series data. So the basic building blocks of time series analysis, or as the components, are trend, seasonality, cyclic variations, irregular components. So let's explain it one by one. Like trend means it represents the long-term movement in the data over time. I will explain. In the case of stock market data, we know that we were saying that there is upward trend in the price or downward trend in the price. So over a long period, by observing the data, we can say that the value is increasing or decreasing. So these predictions we can make with the help of trend. So it is a long-term movement in the data over time. I hope you understand. And it can be, as the example is also given here. So next one is seasonality. Seasonality means over at a particular interval of time is a specific pattern is repeating. A sales is dropped during during a period, or there is a peak in sales at particular times. So these are the seasonality which is repeating in every interval of that particular time. So we can predict in next that interval it will repeat. So seasonality refers to the pattern that repeat at a fixed non-intervals. So it can be daily basis or weekly basis. So I will tell you example. In the case of daily basis, just imagine when we collect the sales report of Flipkart. So during the time between 11 to 12, there is a peak in the sales. Or from the time 5 to 8, there is a peak in the sales. So these kind of time durations is there is a peak. So we can make arrangements accordingly. We can collect the data, or we can give some offers during that period. It will increase the sales, right? Like that there can be sales in a peak in the sales during weekends, like Saturday, Sundays, there is a peak. So we can give some kind of actions during that period. So here example, ice cream sales increase every summer. So for summer season we can make necessary changes. So during holidays there is a spike. So these are the seasonality element within time series data. Next one is cyclic variation. Cyclic variations are the fluctuations occurring in the data. Fluctuations in the sense which is not in a regular way. Some fluctuations happening irregular intervals. So in longer periods, for example, it's different from seasonality. Seasonality will happen at a particular intervals, but in cyclic variations are it's not predictable. Like in the case of stock market, we can't say that there will be a bull in the market during December. We can't say that. So it can happen, but it is not fixed, or we can't predict like that. some recessions happening in the market. Recession is a effect of a long process. So cyclic variations are long term variations happening in the data, or long by the by taking time there are some fluctuations happening. So these kind of fluctuations are called cyclic variations. There are variations are happening inside the data are known as cyclic variations. So irregular or random components in the data, that is the next component, which means noises actually. So in the data, when we remove the trend, seasonality, cycles, what is left over? So that is the noise in the data, or random components. Unpredictable elements in the data is known as irregular or random component. So these happening because of some natural disasters or pandemic situations. During, for example, if because of a negative news, the stock price is down. So it is very short term process, and also happening uh, suddenly. And just move to the other part of time series analysis. So there are different models are available to uh, to predict the future, to analysis purposes. So the first basic model is the moving average. Moving average means we are calculating the average of for example, take 5 days, 5 day moving average. We will take the 5 days average, and take all the 5 days averages, and we will plot. That is moving average, 5 day moving average. We can calculate 20-day moving average. Actually, in the stock market, there are different algorithms or techniques for for not predicting, just we assume that it will happen repeatedly. So moving average is that much popular. And another one is auto regression. Auto regression means we are predicting the future values. So that is another model. And ARMA means the model which will combine this moving average plus auto regression. And another model is auto, the complexity is increasing, right? Complexity and also the capacity of prediction is also increasing when moving from moving average to the SARIMA or Prophet. So ARIMA means auto-regressive integrated moving average. The difference is that here we can use stationary data and non-stationary data. So what is stationary data? Stationary data means it is static data, which means there is no variation in the mean, no variation in the standard deviation. So the data remains, there is no trend, no seasonality. These kind of data is known as stationary data. So we can use ARMA model only for stationary data. When it comes to non-stationary data, we have to remove these trends and seasonality when processing. So that is we can done by differencing. So in ARIMA, we able to handle non-stationary data also. That is the difference between ARIMA and ARM. And another model is SARIMA. SARIMA means we are adding the seasonality component also. So we can handle data with seasonal elements, trend, and non-stationary data also we can handle using SARIMA. And another powerful model is Prophet. And it in Prophet, that is much more easy, and also we can handle all kind of data. And another model is exponential moving average. Exponential smoothing is also known as exponential moving average. Here, with the moving average, we will add a weight also. So that is the difference between moving average and exponential moving average. So we have to learn each model in detail. And this is just an introduction about ARIMA and SARIMA. So as I already mentioned, in ARIMA, these are the parameters which we have to calculate before training the model. So PQR, P is a autoregressive order, and D is degree of differencing, and Q is moving average order. So ARIMA is the most widely used forecasting model for non-stationary data, and in SARIMA we will add seasonality element also. That is the difference which I already mentioned. So the steps in time series analysis, we have to first check the stationarity, pre-process the data, check the stationarity, and as per that we have to choose the model. So for testing stationarity, there is a method called augmented Dickey-Fuller test. ADF test is there. So based on that test, we can we can understand that the data is stationary or not. If the data is not stationary, we have to make it stationary by differencing the data. So, and another method, by differencing, we can find out the D parameter. To find out P and Q, we have to perform another test or another plot, that is ACF and PACF plot. When plotting these two graphs, we understand that value of P and Q also. So these are the basic steps in time series analysis. First of all, we have to collect the data, historical available data, all we have to collect. And after that, we have to choose the model, ARIMA, SARIMA or smoothing technique, which model we are planning to apply, choose that. And then we have to forecast, predict the upcoming month sales, or as what we needed, we will predict it. That is the basic steps in time series analysis. So this is little bit elaborate steps. First, we have to visualize. When we get a time series data, first of all, we have to visualize the data, understand about the data, how the pattern is. And then we have to check stationarity with the Fuller test. Augmented Dickey-Fuller test, we have to check the stationarity. And after stationarity, if uh, there is a requirement to remove the stationarity, we will perform some differencing or decompositions. And then we have to find out the model parameters P, Q, D. For that, we have to plot ACF and PACF plots. Then we will fit the model, then validate the residuals, then we will forecast future values. These are the steps included in time series analysis. So this video, I am only including this much of portion. Thank you.